Hey everybody, welcome to our last flipped lesson in Unit 1. We're looking at Target 7 today, performing operations with our rational numbers. Well, what does that really mean, to perform operations with a rational number? In today's lesson, it means performing operations with fractions. Oh, I know I said the word, fractions. You're all just shivering with fear there, right? I know some of you feel like maybe having surgery from this guy with his saw would be preferable to doing operations with fractions. We know the 1/2 there looks none too happy with that doctor right there. But what I hope to be able to do is give you a few simple rules, go through some examples, and by the end of this video, you'll realize that doing operations with fractions really isn't all that painful. So let's dive right in here. Addition and subtraction. The big thing we've got to remember with addition and subtraction is we've got to have a common denominator to add or subtract fractions. So what does that mean? What does that look like? Let's take a look here. So we have 5/3 plus 8/3. If we look at the denominator, which is the number on the bottom, we can see that they're the same. So we get the green light there. Go. You can actually add these, right? And make Batman happy, right? We don't want to see Batman angry. I think we've all seen the movies. Bane and the Joker can attest. No good if Batman's angry. But what happens if they're not the same here? 3/4 plus 11/6. Here, they're not the same, so we get a red light there. We cannot add. You can't do the addition, or if it was subtraction, the subtraction, if those are not the same. What happens if you do? You're going to make that cute little baby cry. Is that what you want to do? You want to be that guy that's making kids cry all over the place? No, I didn't think so. So the question then becomes, what do we do if we don't have a common denominator? Well, we need to get one. We need to find a common multiple of the denominators and change them, right? Change not just the denominators, but we're going to change the entire fraction so that we can perform our addition or subtraction. So let's look at an example and see what that looks like. So we can see here that 8/3 minus 1/6. This is not a happy Batman problem. This is a crying baby problem if you try and subtract right away here. So the question is, how do we change this? Well, one easy way to do this is to multiply each denominator by the other. So what that would mean is I would take the 3 and multiply it by 6. And I would take the 6 and I'd multiply it by 3. What that's going to do is create a common denominator here. We can see that becomes 18. But we've got to remember our rule of fractions. Whatever we do to the bottom of a fraction, we also have to do to the top of the fraction. What this does is it keeps the fraction actually equaling the same value, just looking a little bit different. So I multiply 6 on the top in the first fraction, I multiply 3 on the top in the second fraction, and what we have here are two fractions that look different, but are actually equal to the same fractions we started with. The reason we want these two fractions, though, is obviously look at the denominator, 18 and 18. So now I can actually subtract. Well, now how do I actually subtract? Do I do 18 minus 18 and end up with 0? No. The denominator is actually going to stay exactly the same. That's why it has to be a common denominator. If it's not the same, when we have it in the two fractions, we can't keep it the same as we start to subtract. Where we actually subtract or add is in the numerator. So 48 minus 3 is 45. The 18 comes across and stays the same. Now, to fully simplify this, though, we've got to make sure we reduce our fraction. 45 and 18 can both be divided by 9, which would simplify our fraction to 5/2. Now that we've looked at addition and subtraction together, why don't you try it on your own here? So in the first two examples, we can see these are our happy Batman problems. And our second two examples, we've got to be careful. Don't make the baby cry. So go ahead and pause the video, give these a shot, we'll come back and check our answers. Ready? Pause. Let's see how you did. So in the first two, we can see pretty straightforward. We keep the denominators the same because they are the same, add or subtract the top. Notice both of these fractions needed to be reduced to be fully simplified there to 2 and -1/6. Now in 3 and 4, we see the denominators are not the same. So we had to do something to make them the same. Now, maybe you didn't end up with the same exact denominators that I did. There are lots of different ways we could make the denominators common denominators. But by the time we're done simplifying, you should have ended up with 3/2 and 5/4, regardless of how your common denominators looked. If you've got any questions on these examples, please make sure you write it down, bring it to class, and we'll talk about it. Well, now that we've got addition and subtraction taken care of, let's talk about multiplication. Now, multiplication might be the easiest one to do because the denominators don't matter. We only care about common denominators in addition and subtraction. Multiplication, 3 and 3, great, green light, go. 4 and 6, great, green light, go. It does not matter. The important thing with multiplication is that we multiply straight across, both on the top and on the bottom of our fractions here. So let's look at our two examples. 5 over 3 times 8 over 3. I multiply straight across 5 times 8 and 3 times 3. I get 40 over 9. That is fully simplified. There's nothing I can reduce there. My other example, 3 over 4 times 11 over 6. I multiply straight across and I get 33 over 24. However, 33 over 24 can be reduced. Both are divisible by 3, so I would simplify that to 11 over 8 there. Multiplication is the easiest one. Like I said, you just have to multiply straight across and make sure you simplify. So that brings us to our last operation here, division. Now, division is a little tricky because we actually aren't ever going to actually divide fractions. What we're going to do is change our division into multiplication. How are we going to do that? Let's take a look at an example. So if we have 5 over 3 divided by 8 over 3, what we're going to do is change the division into multiplication. But when we do that, something else has to change. And what that change is we are going to flip or take the reciprocal of that second fraction. So instead of 5/3 divided by 8/3, we're going to have 5/3 times 3 over 8. Now it's just multiplication, straight across and simplify. In our other example, 3 over 4 divided by 11 over 6, we're going to change that to multiplication and then flip the second fraction there. So then we're going to multiply straight across, get 18 over 44, and reduce that to 9 over 22. One kind of common phrase that I've heard before, which might be helpful to remember, is when we're dividing fractions, remember keep, change, flip. Keep the first fraction, change the division to multiplication, and flip the second fraction. So for division, think of keep, change, flip. Well, now it's time for you to practice. You've got a couple multiplication and a couple division. So go ahead and give these a shot. We'll come back and check our answers. Ready? Pause. So hopefully you're doing the right thing and we're getting the right answers here. For 1 and 2, we should end up with 6 over 7 and 99 over 20. For 3 and 4, we should end up with 14 over 9 and 21 over 55. Remember on 3 and 4, it's keep, change, flip. On 1 and 2, it's just multiply straight across. Well, guys, that brings us to the end. And I don't know about you, but I am all for the next season of Walking Dead. I can't wait to see what happens with the whole Terminus thing. And if you're not caught up, I won't say anything more. I won't ruin it for you. But can't wait to see what happens and find out where we go from here. So that leads us to the end of Unit 1. And I hope you guys have had a great time with these videos and look forward to meeting you again in Unit 2. Talk to you later.